Hello team! Welcome everybody to, what is this, the fourth stream? Number 4. So we've been diving into this gateway, building a cellular gateway for 3 videos now. And you've been taken along the journey of initially starting it up, getting the nodes, the Raspberry Pi set up, the MQTT set up, and then we ran into hiccups when we were trying to glue all of them together. And you've been on the journey with us, debugging everything along the way. I am stoked to share today that we're going to be wrapping up. We have everything figured out. We have all the bugs figured out. We have the code more resilient, and I want to be sharing that with you today. But before we dive in, I wanted to jump on my screen really quick, and I want to tell you how you can get involved. So if you haven't gotten a developer sim yet, I want you to head over to hologram/devplan, and I want you to go ahead and get the free sim that we give out to everyone. This is a global sim, and you have access to the 2G, 3G, 4G, 4G Cat-M1, and 4G NB networks. So definitely sign up and get this. It's free. You get 1 megabyte free a month, depending on what kind of data you're sending. And what kind of platform you're using, or SDKs or raw AT commands. You could send anywhere from 1,000 to 5,000 messages a month. That's enough to send at a minimum every 30 minutes, so that's pretty solid. And this is something I'm really excited about because this is what builds the community. This is how we could knock down one of the biggest barriers to cellular, which is just getting access to the network. So definitely sign up and use the promo code high5, and you'll get a couple extra dollars in there as well. So definitely want to do that. And why are we doing this workshop? If this is the first time you're joining us, I want to head on over to our contest that we have with Hackster going on. And so this is a contest that we had almost 1,000 participants and almost 400 ideas. We sent out 200 kits around the world for people to start submitting ideas. And I wanted to make this video. This gateway is one of the most difficult things to do, but as one of the rewards, the top reward is the best gateway right here on the top. We're going to be giving away Apple Watches. We also got remote controlling, asset tracking, and remote monitoring. All you need to participate is a Raspberry Pi of some kind and the Hologram Nova. The Hologram Nova is available on our store if you didn't get one. And it's pretty awesome, along with the SDK, makes it super simple to integrate cellular into your project. So this is why we're doing this, because gateways are pretty painful. So I wanted to walk through it, and sure enough, it was painful for us, and that's why we're doing video number 3 here to wrap it up. But I hope that this is now a jumping off block where everyone that wanted to make a gateway, which there was a lot of ideas that came in that were gateway centric, you have a solid foundation to now go forward. So without further ado, let's go ahead and dive into this. Let's see here. What do we got? Yes. All right. If you have been following, last week we published the Hackster tutorial. And inside the tutorial, it was linking to GitHub repo and under my account. And I was referencing everything under master. I went ahead and published another branch called Power just before this event. And it's going to go through the code base, the updated code base. I'm going to merge this into master, but there's still a few more things I want to clean up. And the README needs to be updated a little bit more, and then I'm going to port that over to Hackster. But for all intents and purposes, for this stream, we're going to be going through the Power branch. And if you're watching this an hour past the stream, then Power branch isn't going to exist, and you'll just go to master. And so the major things I want to walk through really quick here is I made some big changes hey, if you guys heard Chris in the background. Chris, you got your mic?
Yeah, I'm here. I lost my voice though.
Oh, right.
Yeah. I won't be speaking as much this time.
See, that's what happens when when your face is out of the video.
Yeah.
Yeah, it's like the streaming gods. They don't like that.
Yeah. Or that, or the meetup that we had. We had a meetup on Wednesday or Tuesday in Chicago. So should mention that to people.
That too. The pretty epic meetup.
Yeah. If you're in Chicago, come on by.
Yeah. Look up 3H, Hardware Happy Hour. Super solid group. Amazing time. And we pick a different bar, and we do it I don't know. What are we going to be doing? What's going to be?
Say every other month.
Every other month.
Every other month.
Okay. It's so good that it takes 2 months to recover.
That's right. My voice will be back by then.
Awesome. All right, cool. So let's dive back into this repo. And Chris, if you see anything that I'm missing along the way, just go ahead and jump in. The two main things that we ran into the issue, or before I dive into the issue, sorry that I'm a little scatterbrained. I got to remember that some people are joining us for the first time. So what we're doing here, the architecture, and I'm going to just spend 2 minutes on this, is we're building a cellular gateway, which means that we have a Raspberry Pi out in the middle of nowhere, say, and you don't have any Wi-Fi connection, you don't have an Ethernet connection, or you might have those connections, but you choose to do cellular because it's more reliable. What we're going to be doing is having a number of NodeMCUs in this case, but you can have anything that's Wi-Fi or Bluetooth, connect to the Raspberry Pi. We're going to be doing that by turning the Raspberry Pi into an access point. So we change the Wi-Fi mode of it, so it actually hosts its own Wi-Fi, and you have to then sign into its Wi-Fi. When you sign in, the Raspberry Pi determines an dynamic IP for the device, and then you're able to communicate. We then bring in MQTT as the communication protocol between the nodes and the gateway. Raspberry Pi is the gateway. And then we backhaul it through cellular. So once all the data is accumulated, we're going to send it up to the cloud with the Hologram Nova USB modem that's specifically built for single board computers. And once it's up in the cloud, we got some pretty awesome stuff that we can do in the data engine with Hologram. Up until this point, we've had, you see these boxes here. We've gotten the local Wi-Fi and MQTT working great. We've gotten the global cellular box with the Nova and the Raspberry Pi working great. And we have data in the cloud. The issue is when we brought, what we found was when we brought in both of them together, connecting both of them and running that script, we experienced some odd behaviors with brownouts. And with further diving into it, today we're going to be walking through how to optimize the Raspberry Pi to squeeze out as much power savings as possible so that the Wi-Fi can be more reliable. And at the same time, one of the big issues that I noticed when I was debugging it yesterday was that the script that we were using on the NodeMCUs was not resilient enough. So if the Wi-Fi drops in and out, it really doesn't recover from that. And so I went ahead and updated that script. So we're going to dive into those changes now. If you're new to this project, I encourage you to go over to the Hackster site and step through that whole lesson. The same lesson is on GitHub right here in the README. And what I'm going to do is go ahead and see here. We're going to look at the commits on this branch. And I went ahead and organized it a little bit. And it's given away what the secret is, what we're going to be doing at the end. So I want to step through the first commit that I did, which was changing the power settings or optimizing the power settings to help out with what the issue was. So here we go. Cool. So what I want to do here is if we can get on the desktop or on the tabletop. Cool. So this is what we haven't been able to get going, all this together. Today we're going to do it. So to begin with though, as we've worked in the past, we went ahead and accessed the Raspberry Pi through USB, which is super cool. I love this process. And what we can do is, and you can see it powering up right away. I can even disconnect the power. Whoops. And I want to show you something really quick here. If you can keep an eye out for the LED, this Pi is on right now, but the LED is not blinking. This is one of the power saving modes. So the moment that it boots up, it gets a configuration setting that says, hey, turn off that LED, so it does. But the moment that you apply power, you'll be able to see it flicker, and that's your sign. There you go. See that? Okay. So that means it's on. And then our settings dives in. So let's dive into these settings. Get on my desktop here. I'm going to go ahead and I'm going to go ahead and make it bigger in a second, but just like how the tutorial walks us through, we're going to verify that the device gets registered as an Ethernet gadget. And so it's not connected yet, so I won't be able to access it, but there it is. So it's not connected to the internet, but we can go ahead and access it now. So this is acting as if it's an Ethernet connected to my device, which is pretty solid. Let me bump this up a little bit. Cool. And then what we can do is we could just SSH right into it. And I'm not going to go through the nuances of setting this up. This is in the tutorial. We covered it in the last 2 videos. And at the same time, we also covered how we can then share the internet that I have on my home computer with the device through USB as well. All right, so now that we're in it, one of the first things that we do is we're going to start to optimize this machine like crazy. And I went ahead and talked about the LED. We're going to dive into that right now. So there is config text. I think that's under boot. I think I have this wrong. Yeah. So if you ls this, yeah. And so if I list the root, there's boot. So if I go into boot, the config text should be in there. Here it is. Okay, cool. So I had that wrong. I'm going to have to update that. Let me do a note really quick. Because I know I'm totally going to forget that. All right. Thanks for sorry for radio silence for a second there. But let's go ahead and do that. Sudo nano. I'm going to be using nano to be editing while I'm on the Pi here. And we got config.txt. Okay, so we're going to scroll down to the bottom. We can ignore everything here. And here we go. So these 4 lines I changed. So I went ahead and commented out the audio because we don't need audio. And this DT overlay is actually something that we did in the last 2 videos. This is helping us to enable USB or Ethernet over USB. So we're using that actively right now while we access the Pi over USB. And then these 2 parameters are brand new, and this is to turn off the LED. And so, and this is on the 0W only. So if you're on a 3 or a 2, this active low is actually off. So the high-low is flipped on the zeros. All right, so we're going to exit out of that. And so that's the first thing that we do. After you change that file, since that was under the boot folder, you're going to need to reboot. But before you do that, we're going to go ahead and edit the second thing that we're going to be doing. And you guys and girls might not be a fan of this. But we're going to go into the Raspberry Pi config setting. And we're going to go under boot options. We're going to go under desktop CLI, and we're going to select console only. And so right away, you might have a little drive of adrenaline pumping through because you might know what this means.
Does that mean no UI?
We're disabling the UI.
Yeah, this is like headless mode.
We're disabling the desktop. Yep. Yeah. So on this SD card, I have Stretch, Raspbian Stretch installed, and which is the desktop experience. You can get Raspbian Lite, which is just the console. If you have the Lite version, then that's great. You're going to be saving power already. But with Raspbian Stretch, we can go ahead and turn that off. So we can have it installed if you ever want to turn it back on later, if you do enjoy that. But for all intents and purposes, we're building a gateway that's a little bit of an enterprise situation. We had one of the lights go out, so.
All right, we're going back to desktop.
I don't know. You want me to switch my hat?
Yeah.
Yeah, like this?
Yeah, there we go.
All right.
Benstr after dark.
All right, so while Chris switches that out, Here we go. Cool. That's a great spot to put us in. Yeah, so where I was at is we're going to turn off the desktop. And because of the solution that we're building, the gateway, the desktop, the UI really isn't needed anyway. So you shouldn't be worried about it. We're going to do B1 console. We're not going to automatically log in. And we set that up. And this is going to ask you if you want to reboot now. I don't need to because I already set this up, but this is the time that you can reboot. And then there's one more setting though, so I might have jumped the gun here, but we also do one more. Yes, so here it is. So this is the startup script. So what we're going to be doing is TV service. We're going to be passing -O to it, and what that's going to do is turn off the HDMI. So one thing that I've shown throughout this course is how to run the Pi and work with the Pi and interact with it in a headless mode. And headless means you're not connecting a mouse, you're not connecting a keyboard, you're not connecting a monitor. Because of that, we don't need the HDMI to be on. That's about 100 milliamps.
And that's really how it was designed. Almost everything is based on that, like plugging in a monitor, plugging in a keyboard, right?
Yeah, yeah. To me, that's highly inefficient. Because you're moving to an environment that you can't develop on. Most of the time, you don't have a really nice keyboard even hooked up to the to the Raspberry Pis. And to me, when I first dove into this, I was like, how can I have a better working environment? And so headless was just the natural thing. And it's really simple to actually get that going. So we're not using HDMI, we're not using the desktop, so let's go ahead and turn that off. Also, by not plugging in USB peripherals, we're also having a big power saving there. So everything is optimized. We're cutting down the power drain by 50% by doing these things, about 50%. There's a bunch of articles out there that you guys can read. So let's go ahead quickly and check out my RC local file. We're gonna go down to the bottom. And here we go, you just add that in. Make sure you do it before the exit 0. And we're gonna exit out. And just for good measure, I am going to reboot. All right, and so now I lost connection with that. And while that is starting back up, and when it does start back up, we should see the Raspberry Pi, the friendly Raspberry Wi-Fi network pop on up. And I don't see it yet. Yeah, it's still rebooting. All right, so while that's going, this is taking a little bit longer than normal.
You can always hard reboot it if you need to, right? Just like unplugging it?
Yeah, we can power cycle it. But I tell you what, it has me nervous because every video, it was always planned to go smoothly.
Right. It worked before the demo.
I see it popping up right here right now. So the Ethernet gadget just went up to the top, which means it's starting up, and now it's going to be building the bridge. And if that's the case, friendly Raspberry should be here, and it is. Woo woo. All right, cool. So with this, yeah, that did take longer than normal. Cool. So we have power savings now going, and so the Raspberry is running optimally. Now what I wanted to dive into is what we're going to be doing with this NodeMCU. So let's see here. What can I do here? I don't have any extra long cables, so we're just going to take one of these short ones. And what I'm looking for a cable is that this is a brand new NodeMCU. So I haven't used it yet before. And so I'm going to walk through the script that I have with you guys and girls and show you what I've changed here. So let's go ahead and look at this. Whoops. Wrong setting. I just want to verify. Yeah. Okay, great. Cool. Okay, so before what I was using was a script that was written by the guy who made the library for MQTT and the NodeMCU. And so he had a really nice basic script and it worked really well. So it's perfect for what it was meant to do, was an example and not be very robust. And so what I did was made it a little bit more resilient. And I want to walk through this really quick with you. And this is a little ugly, so what I'm going to do is excuse me while I fire this up. Okay, cool. And let's increase the font on this. So sad. So sad.
You can only knock it down, you can't knock it up?
Yeah, isn't that bizarre?
That is weird. I remember you said that last time, but I didn't see it.
Yeah, okay. So I want to dive down really quick to the things that are different about this. Well, first, if I can explain the problem that we're having. So there's a couple things that every NodeMCU is doing that's part of our gateway. One of the things that it's doing is initially connecting to the Wi-Fi. There's some resilience built into that. So pretty much they call Wi-Fi begin, and we go out and we see if the Wi-Fi is available, and then we wait while it connects. Even if the Wi-Fi is not available, it'll still try and connect and go in an endless circle for that. So that's one thing that we fixed. Then it goes off, and once it is connected, it tries to connect to the MQTT broker. And that is pretty resilient, and that's thanks to the MQTT library. So it goes out and it connects, and if it drops that connection, it reconnects automatically. And that's pretty solid, and it's really sweet, and I like how they did that in the library. But the issue is, what if you lose the MQTT client or MQTT broker connection because the Wi-Fi goes down? And that's the issue that we were having, was with the Wi-Fi losing energy, losing power. It was going through brownouts, and it was sporadic. And so then the Wi-Fi would be dropped, and the code was not resilient enough to recognize that not only was the MQTT broker disconnected, but the Wi-Fi was. And it never was reconnecting through Wi-Fi. And so that's what the issue that we ran into. With the new code that we have, we fixed these issues. So I'm going to scroll down to the bottom here to our setup. And if you notice, the setup is very similar. We call this setup Wi-Fi. We connect to the MQTT broker. And then while we're going through the loop, it's the exact same thing where we have this reconnect function. And before, the reconnect function was just checking for the MQTT broker and fixing that if the MQTT broker was down. Let's go ahead and dive into the reconnection function. So what I did here was added a little if statement, and I asked if the status is disconnected, which that's the status that we're going to be getting if the Wi-Fi was dropped sporadically, then we're going to go ahead and run setup Wi-Fi again, which was the initial setup that we did down here. And so we're going to reconnect. And that's what we're going to attempt even before diving into fixing the MQTT connection. And so let's go ahead and get up to setup Wi-Fi. So setup Wi-Fi has a while loop, and it calls a function repeatedly called connect Wi-Fi. And connect Wi-Fi is the meat of it, where now it's going to, this is very similar to what we had already, but now the while loop is a little bit different. So before, the while loop was checking if it wasn't connected, then wait. And the issue is you're going to be waiting forever if there was an actual issue, an actual error. And one of the errors is no SSID or no Wi-Fi available. And then you get a perpetual disconnect if that's the case. If we're having that, then we're going to break this while loop, which in turn breaks the previous function, and then we're going to try it again. Where this would be in a perpetual disconnect, and after 40 seconds, the NodeMCU will no longer try to connect to the Wi-Fi setting. Now what the script will do is after 40 seconds, it will reset itself and try to do a fresh install or a fresh connection. So you can think that your Wi-Fi could be down for days or for a week, and you can plug it in and the NodeMCU will then connect again. And so what we're going to be doing is I'm going to go ahead and plug this NodeMCU in, and we're going to, this one right here, I have a really short cable, so yep, no worries. And I'm going to flash it. Okay, so it's already registered, USB over UART, and we're going to go ahead and push that up. If everyone who's watching is feeling like I ran through that too fast and I only covered the changes, you're completely right. But the tutorial, the written tutorial, should walk you through all the details of setting this thing up and all the nuances and what you really need. It's a pretty solid tutorial, I think. And I really like the tutorials that walk through every
He's
single
saying that because
detail.
he wrote it. He's saying that.
Well, so, and I also am saying that so that people could be extra sensitive to it. So I think like if I talk it up and it's not that great, people are going to call me out.
I think it's great.
And keep me honest. And that's good. Like, so if there is an issue or if something isn't clear, please leave a comment or an issue in the repo. And definitely would appreciate that. Okay, so this is flashed. I'm going to open up the serial monitor. And this ... is, I'm going to do a hard reset on it so we can see from the beginning. Sorry, I was talking. Okay, cool. So it's going to try and attempt to connect to the friendly Raspberry. And we have this up and running. So it should be able to connect. And it should have already connected, actually. So let's see what happens. So just for giggles, let's see here. Let's double check that I have the right code running here. All right, so what I'm going to be doing here is I'm going to power cycle this Raspberry Pi. We're doing it again. And then we're going to power cycle this NodeMCU. Yeah, that shouldn't show up. Ah, cool. So that's working. So we've been going at it for 40 seconds here, and the network was not found. And so I had it, and here we go. So this is what I was expecting. So it must be, so it has to be much shorter. So the Raspberry Pi must have been in a bad state. So I recycled that, and the NodeMCU was robust enough. I didn't even have to reset it, and it just started connecting itself. And now it's starting to send MQTT messages because it was able to connect to the broker. So let's go ahead and connect to the Raspberry Pi again. And I'm going to start the, the gateway script that everyone should be familiar with. And if they're not, we're going to walk through in a second. So this connects to the MQTT broker, and it's receiving messages from the NodeMCU. And so that's coming through. Woo-hoo! And this isn't new. We've gotten to this point before, so this is great. The really cool thing that I want to show right now is I'm going to go ahead and come back to, I'm going to exit out of here, and I'm going to reboot the Pi. And what happened before, whenever we would reboot or power cycle, that this NodeMCU would just fall off and never connect again. which wasn't really good. So I'm going to show you what it does instead now. I'm going to power cycle the Pi. I am not going to touch the power on the NodeMCU. And you could see that the MQTT connection was dropped. And so it first tried to see, can I connect to MQTT? No. Can I connect to Wi-Fi? No. Wi-Fi is the issue. Now let's go see if we can fix Wi-Fi first before we attempt to fix MQTT. And it's working, which is making me smile. Woo-hoo! We're in business. So the really important thing for this when you're thinking of the architecture is you're going to be setting up these nodes. And if you think of accessibility, first off, you have the gateway connected to a cellular gateway or a cellular modem. So it's going to be out in the middle of nowhere potentially. But then you're going to be connecting to all these nodes around the area, and you could assume that the nodes are even harder to get a hold of and access. And so what you want to do is be able to make the nodes as resilient as possible so that under any conditions they'll be able to reconnect. So if the gateway goes down and you need to replace the gateway, that's great. And the moment, even if you brought in a brand new gateway, the node should be able to reconnect, whether it's an hour, a day, or a month, since they've connected to the gateway, and go ahead and push data in. If you wanted to go more resilient, it would be good to actually put a little bit of memory on each of these nodes so that they could store their data just in case the connection did go down. And so then they could, if they ever did need to catch up in their recording, they could send it again. All right. So here it is. Let's see if it's going to connect. The friendly raspberry is there. I'm just checking this because
So it'll work once, but you're trying to connect again now? Is that the idea?
Yeah, so it should automatically pick up. And I don't see it picking up. Which is, it found the SSID. Because now it's in a loop to try to connect and waiting for it to connect. But I think there's one more edge case that I might need to cover again. I'm going to try to, just for all intents and purposes, I'm going to hit reset. But while we're going to be doing that, I'm going to hit reset on the node, even though that goes against what I was just preaching to everyone.
This is in the interest of time, right? Just
interest in time, yeah.
Moving things along.
Yes. There are, just so that we could show on my desktop here, there are, we're checking the Wi-Fi status. There are 6 statuses going on. So what I'm going to do to debug it later off camera is I'm going to try and get it back into the same situation here, and I'm going to see what kind of status it's passing. Right now I'm working with no SSID, connected, disconnected, and those are the 3 that were the most common before. So I'm curious what's happening here. But I do know that it is finding the Wi-Fi because it's attempting to connect. And it's not disconnected. So I'm curious what the hang-up is. But that's okay. We'll get it connected. And while we're doing this, we're going to get ready to do cellular soon. And so I'm going to connect an external power source. So we can get the tabletop here. Cool. So I want to show you what I have here. This is super cool. This is a power brick that I have at my office. And if you could see, it has different settings. It's passing 5 volts on all 3 of these. But you could step the amperage through. So from 1.5 amps, 2.5 to 3.5. And what I wanted to show everyone here is I also have an official Raspberry Pi plug. And it's interesting here. This works perfectly to what they recommend, the specifications that they recommend. But if, I'm going to attempt to zoom in here and see how close we can get. Yeah, you can see that. Yep, so the output here, if you can read the output, that's telling you that it's exactly what Raspberry Pi recommends, 5.1 volts at 2.5 amps. You're going to find a lot of plugs out there that aren't as powerful from what the foundation recommends that you use. So that's okay with us because I have this power brick and it has a 2.5 amp output. Now, up until this point, we haven't been using the power USB. We've actually been using the onboard USB hub, and you can actually power the Pi through that, which is pretty cool. It's like power over Ethernet, right? Power over USB. I don't know what to say it is, but we're going to go ahead and attach this, and it shouldn't cause any harm. I say that with...
Yeah, right. It bursts into flames.
Yeah.
Sometimes internally they have like power brokering, so I can tell which one to use. So.
Yeah, good point, Chris. Cool. And so with that...
So the LED still didn't light up though. So that's something people should, if they've already turned it all off, that should be...
Well, so it is on right now. And I have the LED permanently off.
Right. I just mean the software's turned off.
Yep. And what I'm going to also do is I'm going to come back over here. I'm going to check if I'm disconnected from the Raspberry Pi. I am. All right, and I'm going to then disconnect from the USB. And now there should be no power here. And I got the plug. I'm going to press this and see. Ooh, there we go. So now it's on. All right. So I have no USB connected to the Raspberry Pi. So how am I going to SSH into this? Well, if you were with us in the last show, you saw that now that this has a Wi-Fi broadcast coming off of it, I can actually enter that network and then SSH into the Pi through that way. So that's exactly what we're going to do. Now that it's fired up, friendly Raspberry should be here. I'm going to join that Wi-Fi. And I'm on. All right.
And you mean your computer is going to join the Wi-Fi?
My computer is going to join Wi-Fi.
Right.
Now with that though, I've lost internet connection.
Right. So you couldn't go to just any website now?
Yeah. In my research, and I was contemplating adding this to the tutorial, but I figured it would complicate things too much. You can, and I'm not 100% sure, but other people have said that they can. You can turn the Wi-Fi, onboard Wi-Fi, into a dual mode, where it could be a client and an access point.
Too fancy.
We've
had enough.
It is too fancy.
Yeah.
But if that was the case, then I could SSH into it and have Wi-Fi be a back channel for connectivity as well. I'm not sure. Okay, cool. So we are in business. I think I did that wrong. No, I did the password right. Awesome. Okay, and I'm looking at, so we're connected here. The NodeMCU is not connected, so I am wondering what's going on here. I'm going to flash it. And while that's flashing, what I want to show you is, what do we got here? I have gateway, which we didn't step through that script. It hasn't changed, but I'm going to show it to you really quick for those who are just joining. Okay, so what this script is doing is it's setting up an MQTT client. So running in the background. So it's kind of bizarre if you want to think about it. Let me... So it's really slow because it's going through my cache. Let's see if it's going to, GitHub's going to let me do that. Here we go. Cool. Woo -woo. Okay, so it's pretty interesting here to think about it, but this little device is an MQTT broker running in the background. The broker starts up at startup. And what you can do is you can also make a script on the same device that will subscribe, which means pull the data in to the script and then do some manipulation to it. And that's what we're doing. These devices can also subscribe to data and publish. They're not subscribing, but the NodeMCUs are just publishing. And so the Raspberry Pi is doing double duty, being a broker and subscribing to the data and then doing something with it. So this script that I have here is doing exactly that. It's becoming a subscriber, and this is all the code right here. Yeah. All right, I'm going to stretch this out a little bit so we can get the whole thing in view. Great. So here it is. We have to specify two things: the broker, which it's a local host because the script is running on the local machine where the broker's running as well, and the topic that we're subscribing to. Get back on my desktop. Yeah, great. Which is node value. If you were part of the previous webcast, we went through topics and how this wasn't the greatest topic. After we step through this example, then I'm going to show you a better example live. So let's hope that let's cross our fingers that we're going to get through the finish line here. And onConnect and onMessage are just kind of functions that get called when the MQTT client loops through and recognizes that there's a connection and there's a message and we want to do some things with it. So really all that we're doing is on Connect, we are subscribing to a topic. So that means right when this script runs, it's going to connect, and once it starts doing that, then it's going to subscribe. Then when it has a message come in, we're going to have it just print out. And we ran this already, and you actually saw it printing out messages. All right, let's see. So here we go. So I don't know what happened in the NodeMCU, but it's been sending, while I've been talking, it's been sending 90 messages, which means it's been 90 seconds. So I've been talking since we did that. So we're going to run gateway really quick. And we should see this. And this is the second time we're doing this in this workshop. Great. And it's coming through. Awesome. So we're going to exit out of that. Whoops, sorry. There we go. Cool. And what we're going to do next is, I don't think I've done this yet. I don't think I've updated the new code. So I'm going to do something interesting. I'm going to show you. I have this app called Transmit, and I like it a lot. But this is FTP client. And the interesting thing is, with FTP, you can actually use it at the same way as use SSH. So what we have here is Raspberry Pi.local is a server, Pi, and Raspberry is my password. And we're going to go ahead and connect. And we're in. This is the whole file system here. And what I have is I do not think I updated this gateway cell script, and so we're just going to update that right now, really quick. And we're going to bring that over. Uh-oh. That was less. That was a smaller size. I wonder what that was all about. Okay, so let's dive back in here. And I want to show you what we have here. So the really cool thing with the Hologram script, and we've updated this, is this is the same library that we've been using before, but I totally forgot about a new feature that was in the SDK. So I want to show you that now. So I did not update the script for the last 2 weeks, or the SDK for the last 2 weeks. So this has been already in here in this version. You've already seen how we're using TOTP, which is a one-time password, where we're not putting in a key in here. Instead, we're passing an empty dictionary, which is just an object. And what that does is signal to the Hologram cloud is to generate a one-time password and verify that the device is not spoofed and sends up to the cloud. Before, what I was doing was calling Connect, Hologram Connect. And the neat thing is we don't need to do that. we're just sending a string. And so when we're just sending strings, there's no reason to open up a network interface now. Now what we can do is totally bypass a network interface on the device and just send a raw AT command to the modem, which then sends a raw string up into the cloud. It saves you on data, and it's way faster and more efficient. So I'm really excited about that. So I no longer need to call connect, and at the bottom, I no longer need to call disconnect. All I need to do is call hologram send message, and we'll send the topics up. So this is all we need to do, and I'm going to go ahead and exit out of here, and I'm going to run this. Oh, and it's going to give me an error. You know why? I didn't connect my modem. Didn't I do this last time? Okay, let's go ahead and do this. Okay, so we're going to walk through this again with the modem firing up. First, it's going to go solid. That means that it has enough power. And then we have another LED, a blue one right here, and that's going to blink once it has detected towers that's compatible with it. And before, that went solid when we connected, but now it's going to stay blinking because we're not going to actually open up a network interface. We're just going to send a raw string to the cloud. So let's do this. All right, so back to my desktop. Ooh, look, it's cycled the Wi-Fi. And just for fun, I want to make sure that we're still connected. Yeah, ooh, look at that, it cycled perfectly, it reconnected. Yeah, baby. All right. So let's get back into this.
So the current working theory is that the plugging in the cellular modem possibly knocks out the Wi-Fi. Okay.
Yeah, and I don't think it's specifically cellular modem. I think it's good practice that when you're connecting peripherals or anything to GPIOs, you should remove power from the device. So I didn't take my advice just now. All right. So,
I suppose another thing is most people won't be plugging and unplugging like this either. They'll just be ready to go. So having just a general reconnect is a good idea.
Yeah. Okay, so we have it now, and that 0 that you see at the bottom means that it went up to the cloud. So we had a message from the NodeMCU, which was hello hologram 247, 248, 249. It went through the script, which we're running right here, the gateway cell script, and then it went up to the cloud. And if everything goes as planned, we send a 0 back, and that's what we did. So what I'm going to do here is I'm going to terminate this script.
Send a 0 back from where to where?
So we send the SDK has error codes, and 0 is a successful message, and then I think 1 through 4 in our documentation specifies what the error is with that. So I disconnected. I stopped the script because if you remember, we're on the Raspberry Pi Wi-Fi right now, and I want to go over to the hologram dashboard, and so I need internet again. So I disconnected. I'm going to jump back on the makerspace Wi-Fi that we're on.
And usually people can do that by going on a different laptop too. It's just that we're on one laptop.
Yeah, good point, Chris. Yeah, this is just kind of like the architecture that we have and the constraints that we have right now for broadcasting. All right, so I'm going to go ahead and refresh to just make sure I'm logged in. I am. I open up the demo, and oh yeah, sure. All right, and so it sent number 255, and here it is, 255, and we canceled the 256 before we got to 0, meaning it didn't complete the round trip. But what was really cool is this was happening really fast. There wasn't a delay at all, or much of a delay in the cellular sending these, and that's pretty cool. And it came right through. Woo-hoo! We never got this far yet. We did it. We did it. Ah! Party. Can you tell I'm a little excited?
So now what? Now
Okay.
what do we do with this stuff?
Now what? So now we got a gateway. Now this is a really raw example of just sending a message from a NodeMCU to a gateway to the cloud. So come on over to my tabletop here. Look at that.
Well, that's a hot mess.
That is. All right. So what do I got here going on here? I got a photoresistor for estimating some kind of brightness or luminosity in a room. I got a DHT11 digital temperature humidity sensor. For those of you who use it, whoops, a little blurry here. Sorry about that. You know that it's very slow and inaccurate. And then I have two LEDs buried in here. Oh, sorry about the mess here. I whipped this together. And this is visually going to tell us if the device is connected or not, because up until this point, we've been using serial monitor on my desktop to see what this device is doing. But if theoretically I have these floating all over my office or somewhere else, I just want to know right away, is it connected or not? And this script will monitor both MQTT and the Wi-Fi. So if either of those are disconnected, it'll show red. Okay, I'm not even going to connect this. This is how daring I am. I'm not even going to connect this to my computer.
You're connected to power, though, right?
I'm connecting it to the power source, the power brick that I showed you. Yeah. Okay. So let's see here. What we want to do here is, since the Raspberry Pi isn't running the script that will read this and send it up to the cloud yet, all we want to verify is that this machine, that this NodeMCU is going to get a green light and connect to the network. It's going to be red at first, and I'm hoping that it'll go green in less than a minute. Oh!
Yeah, that's a really good idea to add those indicators too.
Step
Like
one.
having those visual indicators of like status is so useful for troubleshooting.
Yeah. I'm going to go ahead and disconnect this other Raspberry Pi or NodeMCU, this little one that was just running some iterative numbers. And we're going to come back to this thing now that's doing real sensors. It's doing the real work, man. Okay. So what are we going to do here? Hey, Chris, how much time do we have left?
About 8 minutes.
Oof. Okay. While I'm running through this, I'm going to go really quick. If you have any questions, go ahead and put it in the comment section or the instant message section for the YouTube channel. And Chris will be able to read those off really quick. Okay, but for this, what I want to do is exit out of this. I want to show you what's running on this device. And this is in the repo as well. So this is the exact same script that we were using for the client before, except now I have these sensors in here. And the only library that we're adding is the Adafruit DHT library, which is a great library. Really, nothing has changed. And sorry for the scroll. I know that while streaming, I hate when people scroll. Except for here, we're flickering the lights however we need to when we're setting up Wi-Fi and when we're setting up to MQTT. And then on the setup here, typical GPIO setup and DHT begin for the library. And then on the loop, we're doing just a bunch of string manipulation.
This is going to be online somewhere. Maybe we could
this is all in the repo.
so they could see it online. Maybe we should just
Yeah. Thanks, Chris. And then I'm making an object here. But it's going to be a stringified JSON pretty much. So what we're going to be doing is then we're going to send that up to the cloud. And typically you want to send a JSON object up to the cloud. So that's what's running right now on it. What you can see really quick is though I've changed the topic to something a little bit more suitable where it's environment, which is that's the project that I called it environment, and it's going to be recording from the studio. Now, if you set up another node in a different location, you should change that topic name. Now, what we're going to be running on the gateway is gateway cell sense, and this is it. This is it. This is it. This is how short the script is on the gateway. I've changed the topic that we're subscribing to. If you remember Tuesday, we talked about topics and wildcards. I'm subscribing to the environment and then any room that sends data. So this room that we're in right now is a studio, but I could theoretically set up 50 of these nodes, and they're going to report back, and I'm going to give a unique name to each one of them. And when we're going to be doing that, we're going to be going through every 10 seconds. We're going to grab a message, and we're going to send it up. And what I'm doing here is I'm just adding another topic to the hologram message. Otherwise, nothing has changed. So let's go ahead and move over to transmit here, and we're going to move this over.
And while you do that, SciEst, if there is a log limit in the dashboard, like how many messages does the dashboard log?
So the dashboard is pretty cool, and we're going to, once that's over, great. Okay, I'm going to, where am I connected right now? I'm connected to the friendly Raspberry. That's a great question, and so when we jump back over to public Wi-Fi, after we get a few stuff up there, then I'll show you. All right, so I'm just going to verify that this is what it's called, cell sense. We're going to hit it. Fingers crossed, everybody. All right, connected to MQTT. Oh, and we got our first message in, and this is going to be running a little bit slower. It's going to be running every 10 seconds. Oh, and it's sent to the cloud 0. Woohoo! Got our next message in. This is great. And so while we're going to be doing this, I'm going to, I don't have anything really to cover this thing up with. Let's just see if we can change the luminosity really quick. Yeah, it's going down a little bit. Great, so that works. All right, so I'm going to exit out of this. Oops, sorry, wrong button again. And I'm going to exit out of SSH. I'm going to go ahead and switch over to Wi-Fi now. And let's see what we have over in the cloud. Okay, so I'm going to have to do a hard refresh just because I switched Wi-Fi connections. But typically our dashboard is dynamic enough where it will hot reload in new data. And here it is. We have data in the cloud. Woohoo! Look at that. Oh my gosh, so amazing. I'm stoked. Okay, and when you scroll down to the question here, it will it's really fast, but if you saw the loading screen at the bottom, it loads up. It indefinitely scrolls. You can also access all your data through our API, and that defaults to the latest 25 messages. But you could do up to 1,000 messages that you can get back. And if you want to timestamp it, then you can timestamp it, grab 1,000 at a time. It all depends on how you're consuming it. All right, team, we did this. We did this. We have real data from real sensors coming in through a node that's transmitting through MQTT up to the cloud. Woohoo! And if we wanted to, then we could set up a route really quick. And the really neat thing is, how much time do we have?
1 minute.
1 minute. Okay, we're going to wrap up. But I did want to show you that we have two topics here. We got Environment Studio. We got Environment Wildcard, which means then we could set up routes that we want to trigger just for the rooms, maybe. Say the studio, it's really important for me to keep that cool, but other rooms I'm not. So I'm going to set up an alert or a route just for that. And then I want to set up a general logging route that maybe will go to LoSANT or an S3 bucket that will just take the wildcard, and all the rooms that are reporting all that data is going to be dumped to a third party. And that's what the routes would do.
And we're going to do more streams or more videos in the future about that stuff. So.
Yep. And I'll expand the tutorial that we have, and we'll put a couple routes together to just get people going on that.
Cool.
All right, team.
Where else can people find info if they had other questions or want to see other examples?
Yeah. So what's really great is we've been sending out emails announcing this through our new community email platform. And
we did get the time wrong today, so we do apologize about that.
Yes. We did start at 11:30. Big apologies for that. But you can reply to those emails, and Chris and I will get that right away. If you want, you can dive into the forums at Hologram, which is community.hologram.io, or you can access it through the contest page on Hackster. And that is everything. All right, team. I'm very excited. I'm very happy. I'm going to go to lunch like floating on cloud 9 now because it worked. It's been a long time coming. Thank you for taking the journey with us. I really appreciate your patience, and I really like showing that life really happens to even people that have a professional job like this. All right, team. Till next time.